Very good morning. Today we are going to present our mini project. My name is Fazna binti Majadin.
My name is Kamini Shuri and I'm from Garibaya.
My name is Shamansi Rajendra.
My name is Shakina Shwar.
My name is Oi Sian Sian.
Overview of our project is design network for BITS at Sendirian Berhad with the HQ located in Shah Alam and two branches in Kulim and Skudai. The network includes both wire and wireless connection across multiple floors.
So the problem statement of our project is it's very outdated in the infrastructure and there is no central management of structured IP plan and it has very poor scalability and traffic control.
Our objective of the project: design scalable HQ and branch network, configure all network device, apply VLSM for efficient IP usage in branches, lastly simulate and test connectivity in packet list.
Come to the logistic details. So we have involved PC, wire servers, a switch, wireless PC, a wireless notebook, access point, and wireless router. Next.
So here is the topology diagram based on the requirement. So the left side here is the Shah Alam HQ, the orange, the light green, the pink one, and the brick for Shah Alam HQ. And the light purple here is for Kudim, and the green at the right side is for Skudai. Next.
Okay, accessing scheme, we use CIDR subnetting principle to logically divide 192.168.6.64 block into smaller segment based on floor. Total usable IP address is 2 and subnet network address 192.168.8.64 and subnet mask 225.255.255.192 and IP range 192.168.865 until 192.168.8.126 and broadcast address 192.168.8.127. It's our addressing table, the IP address table for all devices in the HP network. And each device, whether a PC, notebook, server, access point, has been assigned a unique IP address within 192.168.8.64, and we organize as first floor as technical, second floor management, third floor server, and lastly for sales. And each device has specific IP address and the same subnet mask for all device and default gateway as 192.168.8.126 for all device.
The addressing scheme for two branches. So we use VLSM addressing. So the branch network is assigned to 10.0.0/23. Our total IPs is 512, and the goal we want to achieve is divide between Skudai and Kulim. We use CIDR and VLSM principle and to get efficient IP usage without waste. So the device requirement here is for Skudai, ground floor we need 8 wired PCs, and the first floor we need 10 wireless notebooks. So the total is 18 devices. And then Kulim, house A we need 4 wired PCs, and house B we need 8 wireless notebooks. So the total device we need is 12 devices. Next, for the subnet division, we're using VLSM. So VLSM application and subnet design. The entire 10.0.0.0/23 is split into two subnet, which is /24. Each /24 provides 256 IPs, and usable is 254 because we minus 2. So no IP wasted, and we use full use of 512 IPs. So here's the table of our address book allocated for every subnetwork. We can see the subnet 1, 2, and the name is Kudai and Kulim, the network address, the subnet network, the usable IP range, and the broadcast address. And then for device requirement, from the usable IP range, we construct the table for the nodes, which give the name for the node and the corresponding IP address. Next.
For the device setting, first of all, we configuration for the wire host. We choose the technical department TDPC1. First of all, we choose desktop and then click IP configuration and set up IP address, subnet mask, and default gateway. For the device setting for the access point, configure with the SSID called Management Wi-Fi and secure using the password Wi-Fi 1234. This helps to ensure that each department has its own secure wireless connection.
So for the wireless host, we pick any wireless notebook and we have to make sure that we switch off the notebook and replace the modules to WPC 300N. And then we go to the desktop where we choose the PC wireless and we go to the connect tab, refresh and choose the DCN35 because that's the SSID that we have set up. And then key in the password and connect it, and then the wireless notebook adapter and wireless network monitor will be connected. Thanks.
For the configuration of a gateway interface, so we choose branch 2 SCUDA router BR2. So these are the configurations of gateway. That means that we need to key in the IPv4 address and subnet mask that we calculated from our IP address table, and then insert into this text field. And then to our CLI, we also need to add another 2 router, means we are doing the routing configuration. Means we need to add the network and broadcast of another 2 router to make sure they can communicate with each other.
Connectivity test, we verified that the devices in HQ could communicate with the branches. For example, we choose the HQ PC MD-PC1. We successfully pinged the Cooley wireless notebook KLM-NB1 using its IP address 10.0.1.1. Another test was from the HQ wireless notebook SMNB1 to the SCUDA PC SKD PC5, and it also shows successfully connectivity.
Cooling wired PC, we use the Cooling PC2 and connect it to the web hosting server using 11.1, 1.33.2, and we have success. And we also ping from SCUDA wireless notebook to the server HQ. We're using 192.168.8.82. Next.
Router branch cooling BR1 to connect wireless notebook Sukrai and notebook 5 10.0.05. It is successfully connected. And test 2 from router HQ to wire PC cooling. 10.0.1.11 is successfully connected.
From server HQ SFS3, which is ISP router 111.11.11. So here is the result.
Conclusion. So network has met all the ICT requirement, and then VRSN used effectively for branches. So we have also fulfilled the requirement of question, which is each gateway for one gateway for each location, and then move device communication, verify, future enhance one VRAM, firewalls and redundancy, and then ready for real world deployment.
Analysis for the HQ, I use the browser in MDPC7 from the management department to access the web server at http 11.11.33.2 to configure the copyrights.html.
Next one, we use the MDPC7 and we use the 11.11.33 to access the web browser, and we got an image of the Cisco logo.
From branch cooling house A service department KLM-PC1. Here is the appendices. Next.
As final proof of successful implementation, we access a web page hosted on one of the server, http 111.11.33.2. It display conversions from Sukurite First Pro Staff Auto to wireless notebook 1.
Thank you.
That's all from our group.
Thank
Thank you.